talk about loss is that you have to use fishbone diagram. P in, P out, P converted, and in between that you have loss. So this is your losses. P electrical, P core, P friction and windage, doesn't matter which one comes first. P straight. Okay, what else? Then 2.5 kilowatt you have here armature resistance, synchronous reactance, so means that you have to refer to your single phase equivalent circuit as well. Single phase equivalent circuit as well. So sketch your single phase equivalent circuit. RAJXS, so this is a motor, so the incoming is your source, V phase. This is your I armature or I phase. Your JXS, this is your RA. EA. This is your VF. IF. So when you sketch, derive the formula. So VL is equal to 3 times your V phase. This is your V phase. So VL should be bigger, higher. So how much high is times 3? So this is your formula derived from this question diagram. I load, because it just follow the same line, is equal to I phase. Here we have P in, which is equal to P out plus all the losses. P out plus P losses. Ataupun P out plus P electrical plus P core plus P friction and windage plus P straight. So this is the question that can derive from the drawing or your sketch. So we talk about motor. So motor we induce power, electrical power. So we get rotation. Electrical into mechanical. So the equation will be your incoming is V phase. It dropped across your JXS, across your RA, and across your PA, equal to IARA plus JXSIA plus PA. Okay, so this is your equation. So we deal with AC, so put your phasor not indicator. So that's the 3 equation you can derive from your diagram. Then we go to your question. So we have here, it was indicated that your machine is 400 volt. 400 volt, 60 hertz. Sorry, 60 horsepower. 60 horsepower, 50 hertz. 50 hertz, 0.8 power factor leading, 0.8 leading. Y connected, so you have to draw the Y connection. Signal reactance 1.6 ohm, signal reactance 1.6 ohm. 1.6 ohm. Armature resistance is 0, negligible. Okay. What else? Friction and windage 2.3 kilowatt. Friction and windage 2.3 kilowatt. Core loss 1.2 kilowatt. 1.2 kilowatt. Stray loss 0. It's not mentioned. Electrical You have ARA 0, so electrical will become 0 as well. So all the information you sketch and you transfer into your diagram or your concept drawing. So later you don't need to refer to the question anymore. Yes, huh? And this diagram also will contribute marks. At least if you have no idea what to do, so this is sufficient to get at least a few marks. Okay, we go to the question. Motor shaft supply 20 horsepower with 0.8 Nm. 60 horsepower ni adalah rating, how much the maximum your machine can withstand. This is your rating of voltage, rating of your frequency, operating power factor. Alright, rating. Tapi currently it will connect to 20 horsepower, still with rating. So how much is this? And how much at this moment? How much at this moment is your performance instead in terms of your current and your motor behavior. So start with 20 horsepower, then increase into 50 horsepower. Start with 20 horsepower, just narrow this, then increase into 50 horsepower. Start with 20, increase to 50, with condition that constant field current. Field current is constant, it does not change. In that you fix your VF, fix, you just add up load. So what happened here? Magnetic field static or standard or steady state does not change, even though increase from 20 horsepower burden into 50 horsepower burden. So at the same time, your V supply to your system also does not change. You put more load, the incoming voltage the same, the supply electrical field or magnetic field also the same. What happens is that it will draw more current inside your system to cater this load. Because why? Behavior of your motor, behavior of your synchronous machine. And when you start with increment of frequency lah. But when it operates, it will just rotate at the same frequency of your supply. And M or MS is equal to 120 F over P. So your frequency fixed, your speed will be fixed. P is your pulse lah. And it does not change. Dia tak sama macam you punya induction machine. Induction machine ni dia akan ada slip. You put in more load, the speed will reduce because of slip. But for synchronous, the speed will just follow your frequency. It will stick there unless you put in more than 60 horsepower up to your breaking point, so it just break out. Okay, that's the operation or the behavior of your synchronous machine. So for this moment, what happens is that, so when you start with find out what are the efficiency or the performance of your machine during these two operation, these two conditions. So start with at 20 horsepower, what are the performance there? 20 horsepower, efficiency berapa? Kita cari ya. So efficiency is equal to P out over P in times 100%. Start with with efficiency. Find out what are the efficiency. So P out is equal to P in over P out. Cari P in dulu senang. P out P in. P out. So P in. banyak. So P out sama lah. P out is equal to 20 horsepower times 746 watt over horsepower. So you dapat berapa? Horsepower cancel dengan horsepower, it remain as watt. So how many watt? Yeah, at 20 horsepower. 14,920 watt ataupun 14.90 kilowatt. So after you. Then you find out what is your P in. P in here, one we can use P in is equal to 3 VLIL cos theta. But now we don't know yet how much is our IL. So we need to use only this fishbone diagram, which is P in equal to P out plus all the losses. Is that P out plus P electrical plus P core plus P friction and windage plus P3 14,920 plus electrical losses by right. If electrical losses equal to I square R E times 3. This is your losses of your electrical component. But due to we have assumed as RA is 0, so P electrically adalah 0. So P core given as 1.2 kilowatt. P friction and windage 2.3 kilowatt. And P3 also assumed as 0. So you have how much is your P? 3518 boleh? Ha? 420 watt. 18420 watt. So your efficiency becomes 14,920 over 18,420 darab 100% berapa? 81 point kosong sen. 81.0%. So this is your efficiency at this 20 horsepower event. So what happened at 50 horsepower? Once increased to 50 horsepower, so you just repeat. And efficiency equal to P out over P in times 100%. So P out now is 50 horsepower times 746 watt over horsepower. So berapa you punya? P out, this is your P out. Sorry. Apa ni? 37,300 watt. P in equal to P out plus P losses. Okay, during your calculation, please be a little bit hardworking to rewrite the formula. Don't just write the value. P in equal to value. No. Write the formula. Because if you have wrong number, wrong values, wrong answer, so you still have mark for formula. So P out plus P electrical plus P core plus P friction windage plus P3 37,300 plus 0 plus 1.2K plus 2.3K plus 0. So how much PE? 40 800 watt. So your efficiency become 37,300 lagi 40,800 100 berapa? 91 poin 42%. Mata dah kabut tengah-tengah. Dia dah kuat sikit. So in terms of comment, you can comment lower load efficiency low, higher load efficiency increase. So that's in terms of comment itu lah. So you can see the trend. Design is about finding the fact and figure, and trend. Fakta dia berapa, teori, fakta dia berapa nilai dia, is it increase or decrease? So means that this is the performance of the machine. Performance means the efficiency of the machine when undergo these two scenarios, 20 horsepower and 50 horsepower. You see that sketch phasor diagram and the effect of shaft load change. So we have obtained the shaft load changes behavior in terms of the efficiency. Then if you want to sketch your phasor diagram, you need to find. We have been given on RA, JXS, so the unknown is our EA, B phase, I phase. This is the unknown. So phasor diagram, it starts with V phase. And for motor, it's quite tricky. Tadi generator kan? Motor is quite tricky because V phase is the amount of IARA plus JXSIA plus EA. So by right, if in theoretical, betul kan tuan? Ada lagi? Oh, tengok tangan lagi. Buat dulu. Any question on that? Efficiency? Okay, back to phasor diagram, right? Yeah. Phasor diagram. Phasor diagram for your motor. V phase adalah hasil tambah IARA, JSIA dengan DA. Tadi untuk generator, kita mula dengan V phase, follow by your IARA, follow by your SIA. Dia akan menghasilkan DA. And okay, untuk motor dia akan reverse. Dia akan reverse. So still V phase adalah our reference. V phase reference. So it follows because this is leading, so you can note that your current angle is leading. This is your I lah. How much is your angle? Depend lah. Kalau 0.8, so 36.7. Okay, this is we have to find the parameter of your IARE. IARE. So let's say this is your angle, same angle lah. This is your theta, this is your IARE. So now, instead of going forward, so you have to reverse for motor. Motor, you have to reverse. So this is IARE. Say this is your magnitude. IARE, the length of your values. It follows by also your so this is IARE, this is JXSIE. So reverse ini pun akan jadi ke sana. Reverse as well. Reverse. Then this is your EA. So V phase adalah is the amount of IARE plus JXIA plus EA, or EA plus JXSIA plus IARE. It will build your V phase. Voilà. So the arrow will be like this one. From this reference, EA, JXSIA dan juga IARE. So this is your phasor diagram for your motor. And theoretically, like this one. But when we omit or neglect or does not calculate RA, so it becomes 0. Become 0 for this magnitude. So this angle is still the same. The magnitude is reduced to almost 0. So instead, the curve will become like this. Only. Voilà. So the component will be EA and only JXSIE, because IA already being omitted or neglected. Okay? Okay, how to calculate the magnitude and angle? So we have to perform two analyses, which is open circuit analysis and short circuit analysis. So if you refer back to your schematic here, you refer to your schematic, you have this equation. So we analyze on the open circuit and short circuit analysis. So analyze on the first criteria of first scenario, which is at 20 horsepower. So at 20 horsepower, so at 20 horsepower, P in is equal to cert 3 V line I line cos theta. V line I line cos theta. Line here is your line current or voltage in RMS value. If let's say you are given in peak, so change to RMS first. But now, since that this one is already in RMS, so you just use directly and RMS. So we have Pn equal to so 3 V line I line cos theta. The unknown is your I line. V line already there, cos theta already given, P in already calculated just now. So you just put in the value. P in how much just now? Tak tulis kan? 18420 is equal to cert 3 V line is 400, I line is your unknown, cos theta. Cos theta is cos of this angle, which is equal to 0.8. Bukan cos 0.8. So please don't repeat your mistake. So it becomes 0.8. So your I line is now how much? One 18420 divided by 3 divided by 400 divided by 0.8 becomes how much, Alain? Berapa? 33.23 ampere. Okay, dalam phase you have to write in angle. So 33.23 because this angle is in leading lead so 0.8 0.8 dapat apa angle? 6.87 degree ampere. So kalau negative, you put negative. If positive, you don't have to put the mark. So you can start sketch your drawing. Sketch your vessel. So this is your V face, which is 400. Sorry, V face is not 400. V face is 3. V face adalah V line bagi 3. You can calculate anywhere. V face is equal to V line over 3. 400 divided by 3, which is how much? 230.94. So this is your V face. So you can sketch your diagram already. Angle 0 degree volt. This is your V face. And you have your I face, which is, let's say here, theta. So I face adalah 33.23 sudut 36.87 degree ampere. Then this at 20 horsepower, you find your I face. So also at 20 horsepower, V face equal to IA RA, right again, JXS IA plus EA with all the pressure mark being noted. So when IA is neglect, so it remains a V face equal to JXS IA plus EA. Then your unknown is EA. And so EA put this side becomes EA equal to V face minus JXS IA so you put in the values, you have calculated your V face already, 230.94 with the angle 0 degree minus J 1.6 and J 1.6 times IA of 33.23 with the angle of 36.87 degree. So how much is your EA? J1.6, you can write J1.6 ataupun you can write 1.6 with the angle of 90 degree. So, how much? Don't skip to answer directly. Give me your value for
David, 3687 pada mana?
this amount first. How much? J1.6 times 3.23 with the angle of 36.87.
Itu
How much?
art cost 0.8. Dia punya untuk
Okay, for the one first. Because why? We need to find out what is our value of
dia ada cost data
I-
ikut 1.8 kan. So you add
PRA
cost,
and also
you pindah
our
cost ke
value
sana,
of
jadi data ikut tu.
JXSIE.
Okay, thank you David.
So how much? J1.6 times 33.33. Berapa? Ada apa tu ni? Dia bagi komen kat kawan ni? Apa? How much? 53.168. Sudut 226 83 87. Anybody else? Or you agree with this value? 53.168, 126.87. So the value of your EA berapa? Berapa? Dapat berapa EA? Berapa EA dapat? Minus lah. 230.94 minus 53.168. So the angle is logic because you see angle here, which is 90 degree of your current, and here, if you draw here, so this is the angle of your JXSIE, which is 126 just now, 0.87. So the same angle. Angle for IARA here. Angle for JXSIA is here. So it's logic. Fine. So your EA will be here. Dua enam point dua enam. Sudut 9 So this is your value. 266 point. So EA is equal to 266.26 negative 9.19 degree. So this is your delta. Negative 9.19. I assume your calculation got the same value. Angle value of magnitude 266. Magnitude of your V phase 230. Voilà. So this is a so-called quite a logic result for this phasor diagram. So settle for phasor diagram of 20 horsepower scenario. Find out your I phase, V phase, I phase, EA. Is that whatever that mentioned here, but the value is not there, so you have to calculate out. Okay, that's for 20 horsepower. Then at 50 horsepower, you just then increase into 50 horsepower. Increase into 50 horsepower. So at 50 horsepower, what happened? Oh, dah tinggal 4 minit. 50 horsepower, what happened? You cannot use this same formula anymore. Because when it increase to 50 horsepower, magnitude of current will increase. But the angle we still don't know. See? So we cannot use this one because we have two unknown here. IL dengan cos theta. We have to follow or use the formula of formula yang diberikan, which is PA equal to XS. 3B phase sine delta over XS. So this delta is the new delta, delta prime. So this is your new PA. So PA sekarang berapa? Yang 50 horsepower tu? Or you just shift first over here. So sine delta is equal to P in prime times XS divided by 3 V phase EA. EA is your old EA because it does not change the field, so A will maintain. So delta will become sine P in prime XS over 3V phase EA. So you just key in the information. P in berapa? Sekarang yang 50 horsepower tu? P in 40 point 40800 watt times XS of 1.6 divided by 3 V phase U 4 V phase U 230 0.94 EA U 266.26. So berapa you dapat untuk new angle? Angle berapa? Theoretically, when we don't change any field intensity here, EA will maintain. Fixed, EA akan maintain. Magnitude. Means that your length of your EA will maintain, but it will swing further down.
38.
Instead of delta here,